you should have looked at the previous video, and in that video I've gone over a very similar problem, and I'm going to go over another one just to cement your knowledge and make sure that you know what you're doing. So to begin with, we are going to be differentiating by df and dx, so that we have df dx xy and df dy xy. As there is no x term here, we can get a bit excited, and we can see that it becomes minus 2x y squared sine x squared y. So that's df dx. And now for df dy, we have to use the product rule, where u equals y and v equals cos x squared y. This is using partial differentiation. If you don't know what I'm doing, please go to a partial differentiation video that I've put up previously. And so obviously I'm holding the x is constant when I'm differentiating, so I should get x squared minus sine x squared y. So minus x squared y sine x squared y plus cos x squared y. You can put this the other way around, I suppose. But this is the df dx and df dy. So we now have our problem. Now we know that the gradient wants to be evaluated at 1 and pi over 2. So we merely plug in our values of 1 and pi over 2. And so if we get our df dx, which is going to be this bit of this value, and we plug in 1 here and pi over 2 all squared sine 1, you can put this in your calculator. You could do it in your head, to be honest. You should get minus pi squared over 2. And then if you do the same here, plug in 1 or pi over 2 all the way across, you should now get minus pi over 2. That could be our answer. I suppose you could take out minus pi over 2 as a constant, but I'll just leave it as this so that we just have 2 points. And now the same as the previous video, you let u equal alpha and beta, and let it be a unit vector. Sorry, that is very sloppy handwriting. So alpha squared plus beta squared equals 1. We now plug everything in. We multiply everything across. So this direction vector to this unit vector, and we should get minus pi squared over 2 minus pi over 2 multiplied by alpha beta, and it's all equal to 0, as it's stated here. It's equal to 0. And then previously, like I said, I know this is kind of an incorrect way, but there are loads of incorrect ways of just remembering things, I suppose. And alpha plus beta equals 0. So we now know that if we plug in these values, we then get pi alpha plus beta equals 0. We can then rearrange this such that pi alpha equals minus beta, and that means we now have this equation here, and plug in. Okay, let's minus pi alpha equals beta. So we now know, we just multiply both sides by minus 1. We can now plug in this value here. Here. So then we'll get alpha squared plus all squared pi alpha squared equals 1. So we're going to get alpha squared plus pi squared alpha squared equals 1. And then if I keep rearranging this and adding it all along, then I'm going to kind of skip a step because I think the video is getting on. And you should rearrange it to get alpha plus minus 1 over root pi squared plus 1. Now you have your value for alpha. You can plug this value for alpha back into here and get your value for beta. But it worked in the exact same way. If you see, there are just basically two things you need to remember. Alpha squared plus beta squared equals 1. And then this part, this isn't right. You know that it tells you it's equal to 0, but it only equals to 0 once you substitute in your values. So as you can see here, hold on a second. This is also equal to minus pi over 2 pi 1. So taking this minus pi over 2 out as it's a constant, it's constant within everything, you can see that you just multiply alpha by pi and beta by 1 and it equals 0. So you're taking this and you're multiplying, and then you can see it's pi alpha plus beta equals 0. So it's a good way of just remembering, I suppose. It's alpha plus beta equals 0 and alpha squared plus b squared equals 1. But there's another step that you need to take to get this in the correct form. Then it's literally substituting them in within each other, and then you should get the answer that you need.